Here to help you with Chapter 1, Lessons 7 and 8, Solving Addition and Subtraction Equations. So let's carry into where we have been, where we are now, and where we are going. What should you have already learned? Well, really, you should have a deep understanding of what an equation is. More on that in a second. And how about that word solution? That's not something we talk enough about in 5th and 6th grade. We'll talk a lot about it in 7th grade. Now, using that action word, we're going to solve addition and subtraction one-step equations. And yes, that does say one step, which means sooner or later, you can expect to see two-step, three-step, multi-step equations. Now, the key here, we're going to be using algebra, not just using our mental mathematics and our computational skills to get us ready for the more complicated 2 and 3 and multi-step equations. All right, go ahead and pause your video. At this time, name, date, period, whatever the date might be that this is assigned on, page and numbers, assignment number 4. Pause your video. Come on back when you are ready to take some notes. Onward we go, folks. Let's talk about some vocabulary. Notice an expression. We've talked about algebraic expressions before. An algebraic expression is made up of one or more numbers, symbols, and yes, variables. So for instance, 11 plus 4x, that is an algebraic expression. Now, variables, what we can do is substitute in a number. For instance, if we substitute in 4, instead of writing 11 plus 4 of some mystery number, we have 11 plus 4 sets of 2. And evaluate does mean find the final value. So we could do that here. 4 2s is 8. Add 8, and that we get 19. Now, what does an equation mean? Think about the root word of that, equate or equal. So question here is saying, is this a solution? A solution is a number or numbers that makes a statement true. So the question I have is 19 equal to 20? No, that is most definitely false. And therefore, the number 2 that we substituted in is not a solution. 2 does not make this statement true. All right, we could sit here and put in billions of different numbers, or we could use the word solve. Solve means let's go ahead and do all the algebra steps to actually find out exactly what x must be. In order to do so, we will use inverse operations. More on that coming up. So there's your little vocabulary review. Let's get into solution again. Solution is a number of numbers that makes a statement true. It's all about truth. Anybody can come up with a bogus answer, but a solution makes it true. For instance, bottom left corner, 7, is it a solution? Absolutely. Is 7 plus 3 in fact equal to 10? Yes, that is a true statement. Meanwhile, a non-example, 3, is most definitely not a solution. True or false? Oh, this is false. Come on. So it really is about, does it make a statement true or does it make a statement false? All right. So I bet you could pause here and just find what values are the only numbers that will make a statement true. For instance, if I look at that green star, the only thing that's going to make a true statement here is 9. 15 plus 9 equals 24. Put in any other number on the face of the planet, ain't gonna work. How about the top right trapezoid? Well, if we're gonna make a true statement here, the solution must be 96. If you wish, pause, do a little mental math. Come on back when you're ready. In the red, let's try the yellow circle first. In order to be true, you gotta have 82. 82 going down 6 is in fact equal to 76. 56 minus 35, that is the only number that will make a true statement if those two sides are equal. 37 minus 24 is equal to 13, and yes, 24 minus 12 equals 12. All right, now, no big deal for now. Many of you have the mental math skills, but what if instead of 24, that actually said 24,003 elevenths, and that said 12 and 4/10. And yes, I chose to use mixed numbers, whole numbers, fractions, decimals. The point is, it's not always going to be so easy to figure out what that missing number is. So that is where our algebra skills come in. Think about a solution Think about an equation as a scale. If both sides are exactly the same, that scale remains balanced. All right, so it's going to be balanced. On the left side, I have some mystery number, and I have 1, 2, 3, 4, 5 blocks. On the right side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and 11. So this is how we would draw it visually. This is how we would write it with numbers and symbols. What we want to do is take something away so that only the x is remaining. But think about if you just took those 5 blocks off of the scale. What would happen immediately? Mr. Callan, that is no longer fair and balanced. We have a scale that is off balance. So the truth is, if you're going to take 5 away from one side, you must take away from the other. Now that is going to keep it fair. And as you can see, in this case, there must be 6 and 6 on both sides. Now think about what we just did. We just took away 5 from one side, and we took away 5 from the other side. So how can we write that with numbers and symbols? Please notice that anything we do to one side, we must be fair and do to the other. In this case, I will always invite you guys from here on out to cross off inverse operations. The inverse of adding 5 is to subtract 5. And what happens? If you have 5 blocks and you take away 5 blocks, you got 0 blocks. Now, ladies and gents, henceforth, please do not write the 0. That's not helpful to us. So what that leaves us with is our solution. X must be 6. Don't believe it? Hey, you don't have to believe it, but you certainly can check it. True or false? If we were to substitute in 6 into our equation, true or false? 6 plus 5 equals 11. That's true. And I'm going to write that over and over until you get that word into your head, because a solution is a number or numbers that makes a statement true. Please notice, you have heard Mr. Callan in the past say, write the problem, show some work, circle your answer. But now you'll also have a check step. Problem, work, answer, and check it. Problem, work, answer, and check it. That is going to be something you'll hear for months as we talk about solving algebraic equations, excuse me. All right, let's think about this pictorially. What do we want to do? Let's start with writing an equation. On the left side, I see an X and I see 3 additional blocks. On the right side, I see 1, 2, 3, 4, 5, 6, 7. We would like to solve it and get rid of those 3 blocks. But remember, anything we do to one side, we must be fair to the other. So what I just drew was canceling, getting rid of, or eliminating 3 blocks. How do we write that with numbers and symbols? We cancel, get rid of, or eliminate 3 blocks. Noticing that positive 3 and a negative 3 cancel out. I'm going to go ahead and invite you guys to cross those out. And what does that leave us with? Well, the only thing remaining on the left side is X, good, and the only thing remaining on the right side is 4 blocks. Don't believe it? Then check it. True or false? Is 4 plus equal to 7? That is true. And so it works out. Onward we go. Let's take a look at the next equation. If you wish, you can pause the video, come on back when you're ready to check it. I'm seeing 11 blocks on one side. I'm seeing a mystery quantity in addition to 2, 4, 6, 8, and 9 extra blocks. But I don't want those 9 blocks. So let's get rid of 9 blocks over here, and let's get rid of 1, 2, 3, 4, 5, 6, 7, 8, and 9. How do we write that with numbers and symbols? Notice that we have written minus 9 on both sides, ladies and gents, both sides, to keep it fair and accurate. All right, meanwhile, I will invite you from here on out, if you see inverse operations, cross those out. After all, 9 blocks minus 9 blocks make 0. No, you do not have to write the 0. And some people do not like writing 2 equals x. I am perfectly okay if you switch it around. That's the same representation. Meanwhile, true or false. Oh, don't forget, circular solution, Mr. Callan. Is this going to work? Let's take that 2, let's substitute it into our equation. True or false? 11 is the same as 2 plus 9. Shaboom. So it works out. Pause, rewind if you need to. Otherwise, let's get into some more examples. This is the point where I'd start asking for students to say, what is the first algebra step to solve each equation? So picture the x, picture the 21 blocks, picture 34 over here. What are you going to do to both sides? Well, if we want to get rid of 21 blocks, what we would do is subtract it. Again, noticing, please, that you have a minus 21 on both sides. All right, so let me show you now the entire work for this. If we have some quantity, plus 21 equals 34, we're going to subtract 21 from both sides. When we do that, please, please, please get in that habit. Cancel out those inverse operations. After all, 21 minus 21 is 0. No, you don't need to write the 0. The only thing remaining on this side is x, and the only thing remaining on the other side would be 13. Now we'll go ahead and substitute 13 back into the original equation. And is that in fact true? You bet. 13 plus 21 is 34. I would caution you folks, some people do what I call fake checking. Let's say they just compute it and they put 11 instead. And they just write the equation 11 plus 21 equals 34 and put a check mark next to it and call it true, which it certainly is not. So I would encourage some of you to actually just cover up the other side of the equation with a hand or a finger or whatever. Go off to the side, add those together, and then uncover to make sure it in fact works. So no fake checking. You'll hear me say that as time goes by. All right, pause the video if you want. Take a look at the next problem. Identify the first step to that problem, and then go ahead and solve it if you wish. To get rid of positive 15, what we're going to do is subtract 15, and notice we're going to subtract 15 from both sides. Now let me go old school with my pen here. So we got x, we got 15. Don't worry about those bogus steps anymore. In fact, I could just get rid of those so you're not looking at them. All right, so problem, x plus 15 equals 37. Work, algebra step. What we're going to do is we're going to eliminate the 15. Of course, being fair to both sides. Now 15 and a negative 15, 15 minus 15 makes 0. So the only thing I would have left is that missing quantity, except guess what? That quantity is no longer missing. Don't believe it? Let's check it. I rewrite the equation, only now we don't think x is missing. We think we know what x is. We think that x is 22. So again, some of you I would recommend cover up that other side. 22 plus 15 is 37. And that, ladies and gents, is a true statement. Some people prefer a check mark. Some people write the word true. I'm a true guy. Pause, rewind if you need to. Otherwise, let's get into some different kinds of equations now. All right. The reason this one is so different, I don't even know how to draw this, ladies and gents. So let's picture a scale. And on one side, we got some missing quantity. The other side, I'm seeing 47. So imagine 47 blocks. But how do you draw negative 9? I don't know. I mean, some people, I guess you could think of it like a balloon that's kind of lifting it up. And we don't want a balloon, so we want to cut the balloon. We want to get rid of the balloon. Well, how are you going to do that with numbers and symbols? I guess what I would encourage you to say is, look, you want to get rid of negatives. How are you going to get rid of negatives? Or think about this. You have so much money in your bank account, and Mr. Allen was a big old meanie and took away $9. In the end, you got 47. But we want to know what happened before Mr. Callan took that money away. So what should we do? Well, we're going to add the $9 back in. Think about this. A positive 9 and a negative 9 will cancel out. Also notice, once again, ladies and gents, you do see that we are fair to both sides. We keep that equation balanced. Now, when we do so, we find out, hey, that leaves x on one side and 56 on the other, and it seems like 56 is a good answer, but let's check it to make sure it is a solution, that it really is legit. So we're going to take the original equation, we're going to substitute in 56. Some of you even cover up the 47. 56 minus 9 is 40. Hey, it is 47. That is a true statement. So again, the key, I want you to keep thinking about how this is similar to previous problems. Well, anything you do to one side, you do to the other. We have a problem, we have work, we have a solution, and we are checking. But how is it different? Here we had to get rid of this subtract or a negative by adding that money back in. However, I see more similarities and differences. Pause the video if you wish, see if you can figure out the next one, not mentally, but with some algebra steps, and then come on back. To get rid of subtracting 51, we're going to do what? You're going to add 51. Naturally, a positive 51 and a negative 51 will cancel out. Oh, Mr. Callan, that's not fair. Anything you do to one side, we must do to the other. So we're going to show an addition of 51 to both sides. When we do that, we find that our solution is going to be 84. Or is it? Well, if you want to know if something is a solution, you check that work. In this case, 84, subtract 51. Some of you will even cross that off. You'll go off to the side. You'll say 84, 51, subtract, jackpot. True statement. All right, folks, let's pick up the pace a little bit. That's the nice part about videos. Pause if you need, but then come back. What would be the first step of each of these problems? All right, so how do we get rid of a subtract 34? We are going to add 34, and of course, we're going to be fair to both sides. Take a look at what the steps would look like. Minus 34 and plus 34, those are inverse operations, and they will cancel out, leaving us with x is 100. Don't believe it? Check it. 100 take away 34 is, in fact, the same as 36, and that's a true statement. Next up, how would you get rid of subtract 4? Well, look. Let's take a look at choice C. Add 14 to one side, add 14 to the other, so we're fair. Minus 14 plus 14 cancel out, leaving us with x equals, that's what we wanted. Subtracting 0 doesn't really get x isolated and by itself. Subtracting 14, well, that is fair to both sides, but minus 14 and another minus 14 makes x minus 28, and we still have not isolated the variable to get x by itself. That's not helpful to us. So choice C was the proper algebra step. Allow me to show you the rest of those steps, please. To get rid of subtracting 14, we would add 14. Minus 14 and plus 14 will cancel out. Notice that we do add 14 to both sides to keep it fair and balanced. In this case, naturally 0 plus 14 is 14, and go ahead and substitute that number in and check that it certainly does make a true statement. Folks, I am very aware that some of you, it's almost like you can skip the algebra step and figure it out in your head. Great, congratulations, you have great mental math skills and you have some algebra sense, but you must be able to communicate your algebra steps, because when this problem becomes 2x minus 34, when the next problem becomes negative 3x minus 14 equals 50 plus 17x, you might not be able to do it in your head. So you have to be able to learn how to communicate those algebra steps. That's all I got for today, folks. A reminder, please. How are these problems similar? How are they different? Every problem, you are to write the problem. You are to show an algebra step, show your work. You are to circle your answer. And the only difference between previous days, now we're going to check it. Write the original problem, show your work, be fair to both sides. Find your answer, which should be a solution. How do you know it's a solution? You're going to check it to make sure that it makes a true statement. All right, folks, that's all I got for today. Take care, do well, and let's grow.